You're going out with two friends today and you've decided to all meet up at Finchley Road train station. You just arrived on one train, say the Jubilee line, and as you arrived, the Metropolitan line, which is another train, arrived at the same time. Uh-oh, the station staff make an announcement that there's a signal failure causing the trains to be delayed from now on. Jubilee line trains will now arrive every 12 minutes and Metropolitan line trains will arrive every 18 minutes. One of your friends is taking the Jubilee and the other is taking the Met. How long will it be before they may possibly arrive again at exactly the same time? To do this, we can find the lowest common multiple of 12 and 18. So let's do this! Now, regardless of which method we choose to calculate the highest common factor and lowest common multiple of 12 and 18, we always start with prime factor trees. We do this by listing pairs of factors of a number as successive branches in a tree and stop and circle when we get to a prime number. So let's have a go. Remember, it doesn't matter which factors you begin with, you'll always get to the same answer. So for the number 12, I'm going to start with 3 and 4. 3 is already a prime number, so I stop and circle, and that's the end of this branch. For 4, I'll pick 2 and 2. These are also prime numbers, so we stop and circle. Moving on to 18, I'm going to pick 3 and 6. 3 is a prime number, so we stop and circle. 2 factors of 6 are 2 and 3. Which are also both prime numbers, so we stop and circle. And there we have it, our prime factor trees are complete. Now, let's begin with the Venn diagrams method. When using the Venn diagrams, it's easiest to start with the intersection. This represents the common factors of both 12 and 18. Looking at our prime factor trees, we have 1, 3 in common, which we can pop into the middle. And we also have 1, 2 in common, which we can pop into the intersection too. We're then left with a factor of 2 in 12, which we pop into the circle on the left, outside of the intersection, and a factor of 3 in 18, which we pop into the circle on the right, again outside of the intersection, as these are not common factors of both 12 and 18. To calculate the highest common factor, we just multiply the numbers in the intersection together. This would be 2 times 3, which gives us 6. So the highest common factor of 12 and 18 is 6. On the other hand, to calculate the lowest common multiple, we multiply all the numbers in our Venn diagram together. This is 2 times 2 times 3 times 3. That's the same as 4 times 9, which gives us 36. Applying it to our real-life problem, this means that it would be 36 minutes before the Jubilee and Met lines would arrive again at exactly the same time. So if your friends were arriving together, you would be waiting 36 minutes on the platform before you see them. Now there is another method we can use which will get us to the same answers. This is by looking at our numbers 12 and 18 as a product of their prime factors. If we looked at our prime factor tree for 12, we can write 12 as 2 times 2 times 3. In exponential form, this is 2 squared times 3. Similarly, if we look to the prime factor tree for 18, we can write 18 as 2 times 3 times 3. In exponential form, this would be 2 times 3 squared. Then, to calculate the highest common factor, we look at the smallest powers of shared or common factors and multiply them together. Here, both 2 and 3 are common, so we consider them both. But if there was a factor of 5, for example, that was present in 12 but not in 18, then we would ignore it when calculating the HCF. If we look at the factors of 2 in 12 and 18, 2 to the power of 1 is smaller than 2 to the power of 2. And if we look at the factors of 3, 3 to the power of 1 is also smaller than 3 to the power of 2. So our highest common factor would just be 2 to the power of 1 times 3 to the power of 1, which is 6. So again, we get the same answer. Our highest common factor of 12 and 18 is 6. To calculate the lowest common multiple, on the other hand, we look at the highest powers of each factor. In this case, 2 squared, a power of 2, is higher than 2 to the power of 1. And also 3 squared is higher than 3 to the power of 1. So our lowest common multiple would be 2 squared times 3 squared, which again is 4 times 9, which is 36. So well done, guys. We've answered our real-life question. Now you can never say to me, but when am I ever going to use this in life? You'd be waiting exactly 36 minutes if your friends were to arrive at exactly the same time. Now, using this information, can we work out which trains they would arrive on? Of course we can. Maths always has the answer. Let's look at the Jubilee line. Well, we know that the Jubilee line arrives every 12 minutes. 36 divided by 12 is 3. So the friend that's taking the Jubilee line will arrive on the 3rd train. How about the Met line? Well, we know that the Met line arrives every 18 minutes. And if we're waiting a total of 36 minutes, then 36 divided by 18 is 2. So the friend that's arriving on the Met line will be on the 2nd train. Woohoo! We just cracked an exam-style question together. Now it's over to you. It's question time! So I want you to have a go at this exam-style question, which is worth 3 marks. And once you're done, just drop your answer in the comments to find out if you got it correct. So here goes. Matt and Dylan cycle around a cycle track. Each lap Matt cycles takes him 50 seconds. Each lap Dylan cycles takes him 80 seconds. They start cycling at exactly the same time. How many laps will each of them have cycled when they are next at the start line together? This is quite similar to the question that we just worked through together, but I want to hear from you. Let's see if you got it correct. Remember to drop your answer in the comments. Good luck, guys! Remember, guys, if you enjoyed this, please don't forget to hit like and subscribe to be notified of new videos.